In this video, we will see about the experiment Blink LED using ESP32. ESP32 is a controller similar to Arduino UNO. ESP32 is a controller similar to Arduino UNO. So, but in compared to Arduino UNO, ESP32 has a more number of features. So, in terms of connectivity, and ESP32 has a number of applications. Suppose the example you can take the module, if the temperature sensor is connected to the ESP32, so external environment parameter which has been collected by temperature sensor can be sent to the cloud database by creating a cloud account or like that. And even we can able to transmit the data by reading through different types of sensors. That is also possible. And ESP32 is a module as Arduino based module is there, and there is a other product manufacturer, espressif ESP systems is there. And for this experiment, we are using ESP32. Several versions are there. ESP32 CAM and ESP32 SPI, and different modules or different types of versions are there. Each type of module will be utilized for different types of applications. And here, this experiment has ESP32 Grover module, WROVR Grover module, and it is manufactured by Espressif Systems. ESP32 chip that features has it has integrated Wi-Fi and Bluetooth. Plus, it has added on 8 MB of memory of pseudo static RAM is there, and it has an increased memory capacity. Extra RAM makes it suitable for more demanding applications such as voice encoding, music streaming, and MP3 decoding, and even more. And it is a low power sensor networks also it can be used here. But the basic experiment we are doing with ESP32, here it is a blinking LED using ESP32 controller. The required components here you can see the list has been mentioned very clearly. ESP32 development board, breadboard, LEDs, resistors, jumper wires as required based on the number of LEDs that you can connect. Even you can able to blink single LED also just as an experimental purpose. I have taken more than one LED and a PC which is installed with Arduino IDE. And another important keynote for this do the experimental with ESP32 is that we need to install the board ESP32 before proceeding to write and uploading the code. So earlier experiments has been done with the Arduino UNO, but this experiment is been doing with the ESP32 module. For that, we need to first install the respective boards. Boards to this Arduino IDE has to be interfaced properly. That can be done with the procedure. You need to open Arduino IDE, then go to Tools here, then select Go to Board, and go to Boards Manager. Tools, Board, and Boards Manager. Click the Boards Manager. If it is a newer version, it will be appear on the left side of the panel. If it is a older version, you will need to it will be open in a separate window. So here in the search bar, you can enter ESP32. Then you will be identified two types of ESP32. One is manufactured by Arduino and another one is ESP32 by espressif system. Now currently this system has installed with ESP32. See, you can see this list. What I am scrolling down is a list of several types of ESP32s are available in the market. So you can use the different types of ESP32 based on the type of application that can be utilized for different experimentals or mini projects. Any can be use this ESP32. So once you click this button, install button, after typing the ESP32 word in the search bar, install, it will take around a few minutes. So if you have a good internet connectivity, it can be installed at the earliest possible. Once it is installed, then you need to go to Tools and Board, then it is available with the name called ESP32. So here the experiment we are doing with ESP32 rover module. So select this one, rover module. Once it is selected, then the program is to be entered properly without any syntax errors. So here the experiment has been written with considering the three LEDs is to be blink continuously in a serial order without any breakage. And this LED, three LEDs has been declared with the three variables with a name as defined LED1, LED2, LED3. The respective pin numbers are connected with 16, 17, and 18. So this it's been just like a global declaration taken up outside the void setup. So as this experiment has only actuators, there are no sensors, just our activity is to blink LED. In void setup, we can see pin mode declarations has been taken up for three different LEDs. That LED actuator act as an output. So it has to be initialized for all the LEDs, LED1, LED2 and LED3. If declaration is completed, then you need to type the program where the main function execution will be taken up for the operation or for the physical operation to be taken up. So for void loop, you need to go for the type digital write LED high. So we need to make the first LED to be on with the condition writing a keyword called predefined keyword called high. Then it is to make LED on for 1 second. Then once again digital write making the same LED1 to be off condition with the giving a keyword called low. Then once again 500 milliseconds, which is equal to half second. So we need to make it off for the duration ideal. Then once again second LED will on for 1 second, off 500 milliseconds, and third LED 1 second, and for it should be off. So this process will be continued, repeated until power exists to the ESP32 module. This is the experiment program explanation. Let us see the image view, how it will be appear for the ESP32. Here you can see ESP32. This image shows two devices. The right side image, this one is the ESP32 module, where it is been built in with the Wi-Fi and Bluetooth is there, where 8 MB memory is also has been installed, and respective applications for several applications also this can be used. In order to have a better compatibility and better utilization of the board of ESP32, we have been considered another board that is called extendable board. So it is an expansion board written on the board itself, ESP32 expansion board. This board is to be placed on top of the expansion board, so that easily we can able to insert the pins properly. I mean, jumper wires can be utilized with the help of a breadboard, and easily handheld it can be utilized properly for the several experiments. That is the purpose of expansion board. Here we can see the block diagram shows the power supply is given to ESP32 development board, and it has been connected to the three LEDs block diagram, followed by you can see the circuit diagram also. So here the circuit diagram shows that three LEDs has been connected in the breadboard. Each and every LED positive terminal is connected to the a resistor. So you can take any resistor, 100 ohms or 200 ohms or any resistor. So that can be suitable to pass the flow of current to the LED. So and minimum intensity is required to LED to be on condition. It is to be visible. So minimum resistance is to be required. Maybe 100 or 200 ohms is more than sufficient to make the LED. And LED, even if LED has a more wattage power or it has a more capacity to glow, then you can go for the higher resistance valves also possible. So as mentioned in the program, three pin numbers, 16, 17, 18, is the pin numbers that is being connected with the ESP32. So positive terminals is connected to the resistor one end, other ends are connected to the pins. all the three negative terminals, that is the cathodes of LEDs, is connected to the ground, common ground that can be used. Here you can see this virtual representation of the image where the ESP32 is connected with the three LEDs with the help of a resistors. So this is the procedural and the program. Just now we have seen in detailed explanation. Let us see the experiment output, how it will be working. Here in this, you can see the setup that three pins, that is 16, 17, 18, is connected to the positive terminals of the LED, resistors, and the resistor other terminals are connected to the LED part. Okay, so you can see clearly, very clearly. So three terminals of 16, 17 has been connected to the respective resistors. Each resistor terminal is connected to anodes of the LEDs. Three LED cathodes has been grounded. The ground, common ground, is connected to the ESP32, so that all the three LEDs properly working in a manner on and off condition, red, blue, and yellow. So you can have any combination of LED. It is just a normal representation that considering three LEDs to be blink on and off. So this is how the making a blink LED with the help of ESP32. Thank you.